We're going to be looking at scientific notation, but we're going to be actually adding the function of division and multiplication. So instead of looking at this and going, okay, I got to figure out how to put this scientific notation into my calculator, we can actually do this work a simpler way. The key is to remember your rules for when dealing with powers. And with the rules with powers, when you're multiplying or dividing powers, you always want to make sure that the base is the same. But we're thinking, okay, well, but we've got scientific notation. What's the base? And how are the bases the same? Well, if you notice, with every single one of these questions that are in scientific notation, the base is always times 10. So the rule states, when you're multiplying powers that have the same base, add the exponents. So that's what we're actually going to be doing with these two multiplication questions. When dividing scientific notation, the rule states, when you're dividing powers that have the same base, that times 10, the power of 2, or whatever, we subtract the exponents. So, let's do that first. We've got here times 10 to the power of 4, times 10 to the power of 7. So, the times 10 always remains the same. Times 10. Because we're multiplying these powers, we're going to add the exponents. So 7 plus 4 gives me 11. So we've done that part. Now, the only thing that's left is to multiply the first two numbers. 3 times 2 is 6. And there's your answer. 6 times 10 to the power of 11. You didn't have to throw this into your calculator. You didn't have to expand them to figure out how many zeros is this, how many zeros is that. You can just simplify your answer as such. Let's look at now division. As we said, the rule states when we're dividing, right? Keep the base, which is times 10. We subtract the exponents. 9 minus 3 gives me 6, so 10 to the power of 6. 4 divided by 2 is 2. So my answer here is 2 times 10 to the power of 6. Now, these next two look just as simple as the others. But there's one additional step that you need to include at the very end. And I'm going to talk to you guys in a second about that. So, same rules apply. Right? We're multiplying. So, we keep the base, the times 10. We add the exponents. 8 plus 3 is 13. So we know our answer is something times 10 to the power of 13. So now we're going to take our values here, the 5 times the 3, and we get 15. Now, right away, warning bells. If you know the rules for scientific notation, warning bells should be kicking in. And the reason for that is, look at the value here in front of this times 10 to the power of something. That value is greater than the rules that state for scientific notation. For scientific notation, the rules state that the value that is in front of this times 10 to the power of 13 must be between 1 and 9.999, so on and so on. But it's not. It's beyond the 9.9. So, what we want to do is, we want to figure out where is the decimal technically in this question. The decimal right now is right here. Right? 15.0, let's say. We don't want the decimal there. We want it right here. We want it after the 1. Because we want to create 15 in a way that will fit this range. And how do we do it? We have to move the decimal. So if we're moving the decimal to between the 1 and the 5, we get a value of 1.5 times 10. But because we moved in the direction, to the left, we are adding another place value. So we're going to add plus 1 to that exponent. So now this answer, 15 times 10 to the power of 13, becomes 1.5 times 10 to the power of 14. And that is now our correct answer. So if we're moving our decimal to the left, right, we are adding to our exponents. So now let's look at the possibility of having to move our decimal to the opposite direction. So let's go about solving this the same way we did all the other ones. We're going to take the times 10 to the power of 5, and we're dividing it by 10 times 10 to the power of 2. So we're going to keep the base, which is times 10. We're going to subtract the exponents, 5 minus 2, which is 3. Now, we want to find out what our m value is. 2 divided by 4 is going to give me 0.5. And right away, again, warning bell should be kicking in, because our value here in front of this times 10 to the power of 3 is smaller than the lowest number that we can possibly use for scientific notation. Which means this decimal we should not have it there. We need to move this decimal over one place. So the answer should really read 5 times 10, but because we are moving in the right direction, we are going to subtract one place. And we get 5 times 10 to the power of 2. And that is our correct answer.